how do we wrangle all this data? How do we get it under control? What are the things we need to be thinking about even before we start using Purview's technologies? Now, I think of data governance as at the intersection of three IT domains: security, compliance, and risk. And nearly every IT persona in some way has some responsibility for it. Not only that, the results of the work by all these IT data governance people are highly visible to a wide range of executives, leadership, and even government regulators. IT pros must, for example, ensure the accuracy, security, and integrity of financial results reported to the relevant authority, or for reporting on the use of personal customer information across the organization, and so on. Now, caveat, there's a huge overlap between data governance and in particular regulatory compliance. So in this presentation, we're explicitly not talking as much about compliance. So while things like data retention and disposition reviews and e-discovery are huge and important topics, we'll save them for another video, so hang on for a few weeks. Today we're focused on protecting your data estate as you begin to deploy AI applications. But let's be clear, data governance is not simply an IT function. While IT engineers and professionals set up the technical aspects of data, access control and passwords and security and integration and so on, business analysts are the ones that select which data to use and leverage that data for their functions, such as analytics and reporting, forecasting, and so forth. Now, this is a little bit of a preview. It's how Microsoft has designed its tools in Purview with features aimed specifically at the IT technical professional persona and tools for the business user persona as well. And we'll get into quite a bit more detail in just a few slides, but I want to point out that at the top you see an accountable individual, the Chief Data Officer, and I recommend the Chief Data Officer either reporting to or as a peer to the CIO. Why? Because as you saw from the list of challenges a few slides ago, it's a big, all-encompassing job, and it's not something that you can share with other responsibilities. Now, these core principles are really just to help you get started. These are basic, hygienic principles of data governance, and it's a good way to start your data governance practice. The first one's the most important. Know your data, all the locations where your data is stored, what's in them, who owns them, how they're controlled. That's actually a lot easier said than done, as we'll see. Encrypt your data so that it's not vulnerable to hackers. Deploy access controls so that only authorized individuals or software can read, edit, or write data. And use and in fact internalize this notion of the principle of least privilege, which means that instead of giving everyone admin privileges to all your data, only give them the access that they absolutely need for their jobs. It's all on a need-to-know basis. And in conjunction with access controls, create a data classification strategy. Label your content and train your users, maybe even your apps as well, to respect and to use the labels. Keep your data clean, valid, up to date. Understand what laws and regulations apply to you and to your business, and therefore how regulated data must be managed. And finally, since the quantity of data continuously increases, and as often as not, its quality continuously decreases, you must therefore continuously monitor and report on the state of your data. I want to spend a moment talking about just why knowing your data is such a challenge today. All the way back in the 1970s, I worked on a mainframe at NASA, and it had just 200 megabytes, not even gigabytes or petabytes, megabytes of disk storage. And frankly, data governance wasn't a real problem then. There was just one application, not a whole lot of data. But nowadays, our employees are connected with a variety of productivity, communication, and collaboration applications in Office, all accessible via the Microsoft Graph. We might have hundreds of or thousands of line of business applications. It's certainly not unheard of that Fortune 10 or Fortune 100 company will have several thousand applications in these different domains: CRM, sales, commerce, finance, legal, and so on. And we collect all of that in lakes and warehouses and delta lakes and what have you. And it's all potentially accessible instantly by AI. And the architecture of data in the enterprise has completely changed in the last 20 years. Not that long ago, in the 2000s, we thought of the canonical enterprise data architectures having 4 levels. At the bottom, master data management level with core authoritative data about customers and products and so on. Transactional systems, which collected the transactions of our customers. Although all that data flowed up into a relationally based data warehouse, and that flowed up into business-specific enterprise marts, like for special purpose applications like campaign management or forecasting or what have you. This picture, I should point out, is somewhat loosely based on the classic texts on the subject by Kimball and Inman. It was fairly elegant, fairly simple. But now we have many tiers, we have many formats, many structures. Might even have data in several clouds, several speeds. And this is just really to evoke the notion that it's a complicated world. So on the left here, you have all the possibilities for NoSQL databases in Azure, AWS, and GCP, open source, so on. On the right, see you have the relational databases, Microsoft proprietary databases, AWS, open source. And we still need relational databases for the tight integrity constraints to support mission critical applications like ERP. So none of this stuff ever goes away, but we add to it, we add to it, and add to it. And so we get very, very complex, interrelated data ecosystems. And in many cases, one application is moving data from itself to another, and so forth via integration mechanisms. So it can become a very complicated world. And that's why I call it a data ecosystem. So knowing your data can be hard, but it's important. Now, let's talk about encryption for just a second. Some people think that encryption is data governance. And it's true. Encryption can help you protect data from snooping and exfiltration by hackers and so on. But it's by no means a panacea. There's a lot more to it. For example, you need to lock down your data with role-based access control. So even if it's encrypted, you need to decide who's allowed to take a look at it. So role-based access controls, access control lists, and so forth. And so you want to look at this first from the business requirements perspective. Say, what policies do I want to implement? For example, only U.S. HR professionals can access U.S. employee systems and so on. And one other point that I'll make is that as co-pilots are rolling out in organization, doing all of this can take time. It can be resource intensive. You may want to just take an easy way out and use restricted SharePoint search, which is a feature of SharePoint. And what that will do will be to whitelist certain SharePoint sites and prevent Copilot from seeing all the others. And that can be a good way to at least get started using Copilot. Now, another critical activity is to classify your data using sensitivity labels. Now, this means you have to step back and say, well, what for my organization or for your organization constitutes sensitive? And there are degrees of sensitivity, right? Now, the actual labels themselves, it's up to you. You can pick the label, the text of the labels themselves. Microsoft used to use these labels on the left-hand side: high business impact, medium, low business impact, or none, meaning public information. Militaries use top secret and secret. Other organizations use highly sensitive. It doesn't matter. It's just important to know that there are typically content types and information that only selected executives or only selected people can see, that maybe, or content that's somewhat sensitive, but maybe not business critical. Low impact might be things like embargoed blogs. And the entire company can see it, but not the press until a certain date, and so on. So this establishes who can access what, and it limits where the sensitive data can and should be stored. It's important to monitor this. So if you say that a given SharePoint site or a given database cannot have high business impact or top secret data in it, you need to check from time to time. Again, we've said this before, training. Data protection is everybody's business. You need to educate your users to use and to respect labels. We also need to keep our data clean. When we talk about data quality, you often hear the phrase that 90% of all AI is getting the data ready for AI, and it's really true. Why is this so hard? And it is hard. Well, it's trying to decide if the data is correct. Is it properly formatted? Is it even valid? Let's pick an example. So here are 6 different versions of Microsoft's address. Which one is correct? Which one will get the mail delivered properly? Well, if you know if the one on the top left is in fact the correct address. The one next to it is correct, but it has Kirkland instead of Redmond. Next to that has the wrong zip code and it's street instead of way. Still, probably get the mail delivered. But on the bottom left, everything's right except it's Massachusetts instead of Washington. The middle bottom, it's in fact the old address for Microsoft when it was very first founded 50 odd years ago in New Mexico. And then there's another one that's completely made up with an invalid zip code. So the job of data quality is to flag what it thinks is right, what it thinks is, and more importantly, what it thinks is wrong. Here's another example. Which of these email addresses is actually the correct one for Bill Gates? I'll let you do the research and figure out. Now, this can be particularly difficult in certain geographies. This is an example of something that I actually received at my home from India, and you'll see that there's not even a street address in here. It just says this is house number 16, and it's beside certain palace, and that actually gets the mail delivered in this particular location. But how do you decide whether that's actually legitimate or correct? Now, moving on, data governance is a key component of regulatory compliance. And what we've shown in this picture is what I call the regulatory compliance life cycle. It starts with things like the corporate charter and corporate policies and laws from international laws like GDPR, national, regional laws, and industry standards. Then knowing where there's data that might actually be regulated by and covered by those laws, building the protection, and then potentially responding to litigation or legal requests for that data, and also being able to report it on where that data is. This is Barry's law of regulatory compliance. You have to not only comply with all the laws, regulations, and policies, but you also have to be able to continuously prove that you've complied through reporting.